myself where we're not talking or doing anything. Listen to what I'm saying and thinking as I go along. So, an orange and a cup of juice are 210 calories. An orange has 90 calories. Write an equation, I see the word equation, so I know I'm going to have an equal sign, to show how many calories a cup of juice has. Well, let me draw this out for myself. So I know I have an orange, and it says, and a cup of juice, so I have two things, and only when I have two things, I'm adding those together. Let me see if this will focus. So an orange plus a cup of juice are 210 calories. Well, that's a total. So there are 210 calories together. Write an equation to show how many calories of juice each cup has. And the orange has 90 of them. So over here, I'm going to put 90 by my orange. I know the total. To make an equation out of this, well, I know I do not have what the juice is. So I'm going to put a variable here. So now it's time to write an equation. Well, based off my picture, all I need to say is 90, which is the orange, plus, I do not know the juice, so I'm going to use a variable, plus x, gives me my total, and I'm going to use an equal sign because I see the word equation, I know it has an equal sign, equals 210. Then I'm just going to box my answer because I'm done. Azalea?
Aren't you supposed to track the answer? Are you?
We're not solving today. So we're not solving. We're a little bit ahead. Because we did this during ELT. So you all already kind of know that we're going to be solving them. But next class, we're going to be solving them. Today, all we're doing is writing them and using pictures on some of the problems to pretty much get us there. But next class, we'll solve them out, okay? So right now, 90 plus x equals 210. And that's all I have to do. So we're going to look at example 2, but this time you guys are going to kind of help me out as we draw the picture, okay? So let's actually read this one as a class on my cue. So when I say 1, 2, 3, my pencil is going to go to each word. We're going to read it together, okay? 1, 2, 3.
Steve is 3 times as old as Tony. Steve is 18 years old. What equation can you write that would be used to find Tony's age?
All right, so Steve is 3 times as old as Tony. Steve is 18 years old. What equation can you write that could be used to find Tony's age? Well, before we write anything, we're just going to draw a quick little image. So obviously, I need an image to represent who? Steve. So I know I need an image to represent Steve, and we all know that I am not the best drawer, but here goes. So I have Steve, right? And it says Steve is 3 times as old as Tony. So what operation do I need to be in between Steve and Tony? I'm going to put multiplication, and remember this is 6th grade, so we use a little dot to represent multiplication. So Steve is 3 times, and you know, beneath my images, I like to put the number. So I know Steve is 3 times. Who should go after this? Tony. So let's draw Tony. Well, we can't make him look the exact same, so long hair? Okay. Tony can be a girl. So Steve is 3 times the age of Tony. Did it tell me Tony's age?
No.
So what do you think I should put right here?
A variable.
Nope, I don't hear math terminology. What should I put here?
A variable.
So I'm going to put a variable here because I do not know Tony's age. And then it says Steve is 18 years old. What equation, there goes that word equation again, so what am I using for an equation?
Equal sign.
So I know I need an equal sign. So what equation can you write that could be used to find Tony's age? Well, I know it's equal to whose age am I looking for?
Tony's.
Tony's. Am I looking for Tony's age?
Yes.
I am looking for Tony's age, but before I finish this equal sign, let's take one step back. Steve is 3 times as old as Tony, correct?
Yes.
Steve is 18 years old. What equation can be used to find Tony's age? So I'm looking for Tony's age, but do I already have my total? Do I have my total? Did this problem give me a total already?
No.
I heard a yes. Jalen, why did you say yes? Okay, I heard a no. Raise your hand if you said no. Jamin, why did you say no? You said, say that one more time? He said it didn't give us the total age of both of these. Well, let's take a step back. So if Steve, which is right here, he's 3 times the age of what? Tony. Then what did it say? Steve is what? 18 years old. So what equation can you write that can be used to find Tony's age? Well, do I know how old Tony is? So what did I plug in there? Do you think a problem would give me 2 variables?
No.
No. So why is this so significant when I said Steve is 18 years old? In order to figure out how old Tony is, I know I need to multiply that by 3 times, right? But then that would mean I would need to know how old, exactly, I hear the old. I would definitely need to know how old Steve is, correct? Exactly, so it did actually give me my total. So I'm going to plug in 18 where? In the total spot, right behind the equal sign. So now when I write this equation, I have 3 what?
3 times x.
And listen very closely. When you have a number and a variable right beside each other, what operation is that? Multiplication. So we got to get familiar with actually writing it right there. We will not put a little dot in between it. We're going to actually put 3x equals 18. And we'll box our answers when we're done. The Steve on my PowerPoint is so I better just look at mine. Okay, now this second little half, because I told you we're going to break class up into 2 pieces. This second half we're going to do whiteboard practice, okay? So I'm going to pass out some whiteboards. And there are going to be problems that come up on the screen. We're going to use pictures first to lead us into like equations, okay? I don't have the marker. We're going to pray that all of these words when I pass them out to you. Yeah, thank you. Grab those 2 markers off those. Good job, that marker. All right, class.
Yes, yes.
All right, so here's the first one. And I'm going to time us. I'm going to put 3 minutes for the first one. But our time will decrease as we keep going. So let me be a little explicit here. So you're going to read the problem. You're going to draw an image to represent when you're reading. And then you're going to create your equation. And and box your answer once you are done. When the timer goes off, you will then hold your board up and we will go over it. The 3 minutes is starting now.
Say 3 inches shorter than the operation is only 10 minutes. If something was just a little bit shorter, what would you want to do? If it's less than, a little bit less. Less. Exactly. So if it's shorter than.
All right, class size?
Yes, yes.
All right, when I say go, you're just gonna hold them up. Go. Jalen, turn yours on. All right, put them down. Okay, let's take a step back and talk about this problem. So this is just up for, I need a marker. I gave y'all one. Okay, so Samaria is 3 inches shorter than Charles. So I saw people with Samaria on there. And then I also saw 3 inches shorter than Charles. And I saw some subtraction, and then we drew Charles. Let me give him a sad face because guys normally don't like to be shorter than girls. Who is 62 inches tall. So do I know Samaria's height? Samaria is 3 inches shorter than Charles, who is 62 inches tall. So whose height did they give me? Charles, who's 63, which equation can be used to, 62, which equation can be used to find how tall Samaria is? So who am I looking for here? I'm looking for Samaria's height. I know Charles is 62 inches tall, but what other significant information did they tell me?
3 inches shorter.
The difference between them is what?
3 inches.
So I know that if I was to take Charles and subtract it by what? 3, which my people are backwards. If I was to take Charles and subtract it by 3, I would get whose height? I then would get Samaria's height. No. I just said my things are backwards. So it needs to be flipped. So 62 minus 3 gives me, when I write, this is just a picture. Remember, your picture is just to help you imagine this. But when I'm writing it, I'm going to say 62 minus 3 would give me Samaria's height. So my equation should have ended with 62 minus 3 equals x. When I looked around the class right now, we were at about not even 50% of us having this, okay? So this is just problem 1. We're going to try another one, okay? Catch that. Here's the next one. So this is one way to do this. So I gave you one. Okay. So you want to use it, I'll give you three more. Yeah. So I'm going to put it together. And then I take some honey. Seven. So then I'm missing. So I know if I repeated 7 about how much one ticket costs, then it would give me. Yeah, that's what you already have made. So let's rewrite it in that.
Yes.
Class start.
Yes.
When I say go, you're gonna hold them up. Go. Rachel, who can see this? Hold them to me, y'all. But Thomas, I can't see this one. This table, put them down. This table, put them down. Put them down. All right, let's talk about it. Thank you. Okay, so I'm seeing two different strategies happening here. Technically, we're at about like a 55 right now on this one percent of the class. I have half the class actually creating the problem that this one is asking for. Then I have another class creating their own problem solving strategy to come up with the answer. So let's talk about it. Some of us are saying, oh, well, if I just take 35 and divide it by 7, that will give me what I'm looking for. But in reality, this problem didn't ask me to divide 35 from 7 in order to find my answer. So we have to be able to read a problem and actually write exactly what it's asking us for. So let's look at it. I have how many tickets here? 7. So if I was to draw movie tickets, and let's say that I had 7 of these. And then it says, 7 tickets to the Children's Museum cost how much money? $35. So I know that all 7 of these tickets together is going to give me what as a total?
$35.
So I know I'm going to spend $35 that day. Which equation can be used to find out how much one ticket costs? What am I looking for again?
One ticket.
So what is my variable here? What is my variable? What am I looking for?
One ticket.
One ticket. So I know my variable is going to be my ticket, right? So I know I need to put an X for my variable. But what do I know about the tickets? How many of them did I get? 7. So what operation do you think that is if I'm missing, don't say it yet, you actually got yours. If I'm missing the cost of one ticket, but I know I bought 7 of them, to give me a total of $35, what operation do you think I'm using?
Multiplication.
Don't blurt out answers. I want you to turn and talk to your elbow partners for 10 seconds. What operation do you think I will be using if I'm trying to find out what one ticket costs and I know I bought 7 of them and it led me to a total of $35? Go. And I have a total of $35. And I have an equation. How can I get $35? The number 7. What was I supposed to do? Actually, you're taking it to solve it. Solve it. What is that? You know, the fact that since we already started to solve these.
Okay, student grade, because that's student grade.
All right, class. So what operation would I use here?
Multiplication.
So I'm going to actually say, well, if I have 7 of these tickets and I multiply it by the unit of 1, which is my unit rate, so my unit of 1, what one ticket costs, then it will lead me to what as a total? 35 as a total. So your equation should have been 7x equals 35. All right, we're going to do one more? Sorry.
Class, read the first sentence with me, please. Ground beef is being divided into 4 hamburgers. What am I starting with? No, listen. What did they tell you first? What do we have? We have balloons. What do we have?
Ground beef.
Ground beef. Like a picture of ground beef. Just draw a square. I don't care what it is. Okay, there's my ground beef. That's your picture, right? You went to the market, you bought the ground beef, right? You got it there in front of you. Now read that sentence with me again. Ground beef is being divided into 4 hamburgers. What did it say we're going to do to that ground beef?
Divide it into 4.
Divide that ground beef into 4 hamburgers. I don't care if you do it forced that way. It doesn't matter if you do it the other way. As long as you have that ground beef cut into 4 parts, equal parts preferably. Sorry about my picture. So I want you to visualize that, right? I've got this pack of ground beef, right? Once I divide it into 4 parts, right? Each one is going to weigh how much?
6 ounces.
That's how much it's going to equal. Each one, once I've divided them up, it's going to equal 6 ounces. Do I know how much I started with?
No.
Do I know how much I started with? Do we know the exact amount of ground beef that I bought at the store?
No.
No. Do I know how many parts I divided it into?
Yes.
Yes. Do I know how much it equaled once I divided it into those parts? Yes. So what part is my unknown? What is my what? My total, the amount I bought to begin with.